Hello, it's great to see you all again. Immortality is one of humanity's oldest desires, but medical advances suggest that our physical bodies seem programmed to die. After 100 decades, in 1961, Leonard Hayflick realized that all normal human cells divide 40 to 60 times before entering a phase of senescence and dying. Today, we call this the Hayflick limit, and you can't build an everlasting house if the bricks that make it up don't have eternal durability, right? That doesn't mean that humans can't become immortal, just that you'll need to look at it differently. Many believe that humans are actually composed of two parts, the body and the mind. If we can separate the mind from the body, we will no longer be bound by the Hayflick limit or the ticking time bomb of the thing that contains our minds. Just like all the data on your old iPhone can be copied to a new iPhone, some scientists believe that information in the brain can be transferred or copied, in part or in whole, to a USB drive or another brain. In this video, we will discuss the possibility of creating a version of immortality by backing up the human mind. First, why would you need a brain on a USB drive? Imagine that while cleaning your house, you find a hard drive containing 1,000,000 bitcoins that you forgot about from 2009. One bitcoin at the time of this script, on September 3rd, is worth $57,860. So with 1,000,000 bitcoins, suddenly the hospital informs you that you have terminal cancer and only have 3 months to live. You're in despair when you suddenly remember that you have $57,860,000,000 in your account. You contact the top doctors on Earth to buy immortality. They all shake their heads, but one person holds out a USB drive and says, "I will copy your brain onto this USB drive." With it, you can not only live forever, but also go back and relive your life at your prime whenever you want. Just plug in this USB drive, press the download and install button, and you're done. This is a fun scenario that Amazing Anomalies made up to help you visualize one of the applications of mind uploading technology. It's the process of digitizing the brain, which contains all of a person's memories, emotions, experiences, and personality, and then transferring all that data into a computer or robot so that the mind can live on even after the physical body has died. In this way, futurists believe that humans will be able to prolong life or even achieve digital immortality. Some other purposes of mind uploading include creating permanent backups that can be loaded into supercomputers to control spaceships exploring space between the stars, searching for extraterrestrial life. These USB astronauts could fit into spacecraft weighing only a few grams, such as the Starship. They wouldn't be affected by the vacuum of space, microgravity, or deadly cosmic radiation, and they would allow for explorations of unlimited duration. Unlimited here means until the spacecraft breaks down. Or, closer to home, minds living in computers could become the ultimate legacy after our human civilization suffers a global catastrophe. On a more optimistic note, human intelligence, once uploaded to a computer, would function like a computer, meaning it could think much faster and, therefore, be much more intelligent than its former owner. A system of uploaded minds connected could propel technology to develop exponentially, even reaching the ultimate peak of technology, known as the technological singularity. However, is that idea realistic? Mind uploading is not easy. In fact, it's so difficult that many consider it the most challenging level, the final boss of neuroscience and computational neuroscience. Neuroscientists believe that the most important functions of the mind, such as learning, memory, and consciousness, are due to purely physical and electrochemical processes in the brain and are governed by the laws of physics, chemistry, and biology that humans already know and understand. So why hasn't anyone copied their mind onto a USB drive yet? In the past, scientists have repeatedly tried to simulate parts of the human brain. Based on these simulations, they estimate that if Moore's law continues to hold true, we will have enough computing power to upload an entire human mind in the next few decades. But there's a problem. Moore's law predicts that the computing power of chips will double every 2 years. This law has held true since 1975, But since 2010, the power of microprocessors seems to have fallen behind this trend. In other words, it seems like we're approaching the limits of computing power. But that doesn't mean humanity will never have enough computing power to upload the human brain. Because, frankly, no one knows how much we'll ultimately need. We only know it will be incredibly massive. You may have heard somewhere that the human brain has 86 billion neurons, and each neuron can have up to 2,000 or a maximum of 15,000 connections with surrounding brain cells. This creates a super complex network of over a quadrillion connections inside your skull. The cerebral cortex alone, the wrinkled outer part of the brain, contains up to 125 trillion synapses. That's equivalent to the number of stars in 1,500 galaxies like our Milky Way. And that's just the tip of the iceberg. If you want to copy a mind to accurately reproduce the brain, we would need to precisely simulate nearly 100 billion neurons and a quadrillion connections between them. The problem is that each individual neuron itself, an incredibly complex and powerful biological supercomputer. You can't just assign it X, Y, 0, or 1 and be done with it. To digitize just one neuron, you would need to simulate the structure and function of hundreds of thousands of billions of atoms, thousands of billions of molecules that make up that neuron, as well as all the rules governing how each molecule interacts with each other. This task would require computers thousands of billions of times larger and more powerful than anything we have today. According to pages 80 and 81 of a 130-page study in 2008, to simulate a molecular model of a brain, including the position and random behavior of each individual elementary particle that makes up that brain, we would need a processing capacity of about 10 to the power of 43 flops, along with about 38.8 thousand trillion terabytes of memory, equivalent to 78,000 trillion iPhone 15s with 512 gigabytes of storage. While you're still grappling with 10 to the power of 43 flops, that's 8 sextillion times the computing power of the world's most powerful supercomputer at the moment, Frontier. Frontier costs $600 million, consists of over 600,000 CPU cores and more than 8 million GPU cores, occupies an area of 680 square meters, and consumes nearly 23 million watts of electricity. Yet, it only meets 1/8 sextillionth of the required computing power to simulate the brain at the molecular level. Another way to put the brain on a USB drive is to take a picture of it. In 2010, researchers at the Stanford University School of Medicine successfully photographed synapses from a part of a mouse brain. To do this, the researchers cut an extremely thin slice of the mouse's cerebral cortex. Yep, they cut the brain. Are you still excited? This brain slice was only 70 nanometers thick, equivalent to 700 hydrogen atoms lined up next to each other. The brain slice was then stained with a type of antibody to emit different colors. The final product is what you're seeing on the screen. The images obtained show that it's thousands of times more complex than we thought. Each synapse, each colored dot you see on the screen, which we previously thought was just a simple on-off switch, turns out to be a microprocessor, a tiny biological chip with both information processing and memory functions. In addition, synapses do have switches, about 1,000 switches per synapse. Added together, a complete human brain has more switches than all the computers, routers, and internet connections in the entire world. In other words, your brain alone is more massive than the entire internet. In conclusion, simulating the brain or digitizing the mind is a crazy idea, but that's precisely why it currently lies entirely in the realm of science fiction. If you like the idea of copying your brain onto a USB drive, remember to like, subscribe to the channel, and hit the notification bell to receive the latest videos. And now, goodbye and see you again.